All right, good morning everyone. Welcome to week 15. We are still working on geometry unit 4. We're doing 2 sections today because we covered 407 last week. So we're doing secants and tangents part 1 and 2. So everyone take a quick second and copy down the week 15 essential question. Please give me a green check mark when you are ready to go. So go ahead and continue writing. I'm just going to read it out loud. It says, when you have 2 secant lines that cross inside a circle, what formula do you use to find the measure of the interior angles? So obviously this is not one where I'm asking you your opinion. This one is just going to be a very specific formula. So I'll give you another 30 seconds and then I will put it up again at the end in case you didn't quite have a chance to copy that down. All right, so we're going to move forward. If you didn't quite get a chance to write it down because you got here late, I saw a couple people just join. It will be up again at the end. So let's jump in with a quick review from last week. Last week we learned about this inscribed angle theorem, and what we talked about was what is an inscribed angle. And an inscribed angle is one that touches the opposite corner of the circle, and then it has this really cool formula. So one angle is going to be x, and then the outside angle is 2x. But that's only true when one touches it outside of the circle, and then you're talking about the corresponding arc. So we're going to try a few. I have these examples for you on your notes, so let's fill them in together. Here we go. So we're starting on example 1. Did everybody find that box on your notes? Example 1. I'm telling you that the outside arc is 100. Don't say it out loud, but please fill in what x would be. So the outside arc, 100. Let's fill in what the inside angle would be. Notice what I'm asking. One's an angle, one's and the arc measure. See how they're a different question, right? One's an angle inside, one is the measure of the arc. So if the outside is 100, a lot of you typed it in, the inside would be 50. Great, thank you. 50. The relationship between the two is this one is x, and then the outside is 2x. So when we're looking at these problems, I always want you thinking in your head, the outside one is always more than the inside one. How much more? Twice as much. So let's look at my second example on the same page. This time I'm asking you what the outside arc is if I give you that the inside is 64. So take a minute and work that out on your paper. Okay, Anthony, what do you think? 128. 128, good job. So your inside is your x. Outside is always twice as much. Any questions before we move forward? Okay. Yes, question. Does it have to equal 180? Okay, does it have to equal to 180? Good question. What exactly equals 180 in math? Let's talk about that. Half of the circle. Okay, half of the circle would be 180. So from F to D to E, that would be 180. Yep, the whole half arc would be 180. What else in math always equals 180? A triangle. Okay, the 3 interior angles of a triangle always equal 180. Everybody okay with that? So those would be the 2 things that equal 180. Half the circle or the 3 angles inside a triangle. Great question. Okay, next example, because this is more like what it looks like on a quiz, right? They don't always give you like the easy version where it's like, oh, I take half of this number. They're going to throw some variables at you. So let's think about what we know. We know that the inside we usually call x. The outside is twice as much as the inside. How would I solve this problem? You're right, I need to solve for x. how do I do that is the question. If I know the relationship between these two, here's my inside. I know that the outside is twice as much as the inside. What does twice as much as the inside really mean? It is a proportion, but what kind of a proportion? What does twice as much mean? What number is that? 2, okay? So it's twice as much as the inside. Which one's the inside?
X plus 5.
The x plus 5. So let's write it this way, ready? So the outside equals 2 times the inside. So let's start there with that phrase, and let's make sure everybody's on the same page with me. So the outside equals 2 times what the inside is. Is that a true statement? You guys okay with that? Because the outside's bigger, right? The outside is 2 times what this little inside is. So now we're going to fill in our numbers here underneath it, and it's going to make sense. My outside is 3x minus 40. And my inside is x plus 5. What would I have to do to solve? What would be my first step? Okay, not divide by 2. I would want to distribute first. So 2x plus 10. Now it becomes an algebra 1 problem where we just have to get all my x's on one side, all my numbers on the other side. So let's do that. I'm going to move my 2x over. And then I would add 40. So even though I've been teaching math for 15 years, I still show all of these steps. I don't do these steps in my head because what I find is when I do them in my head, I'll miss a sign somewhere. Maybe instead of minusing 2x, I'll add 2x. It has to be a visual thing for me, otherwise I make simple mistakes even though I've been doing this for a third of my life. So I encourage you guys, always show your work. Even on the quizzes where you get a multiple choice, you still should have paper out, right? You should still be working these problems out on paper. Let's see if my answer makes sense. So my x is 50. Let's plug in a 50. So this would be 50 plus 5. And this one would be 3 times 50 minus 40. So let's do this inside angle first. 50 plus 5 gives me 55. My outside angle, 3 times 50 is 150. 150 minus 40 is 110. Is this correct? Does this hold true with the formula? Here's my inside. Is the outside twice as much? 55 and 110? Yes, I did a perfect job. So by us taking my answer and plugging it back in, I can double check that I did it correctly. If you got an answer like this, if I got 42 here and 96 in here, oh, I definitely know I did something wrong. Do you see what I mean? Because the outside always has to be double what the inside is. So there's always a way for you guys to check yourself and check your work. So that's kind of as hard as it gets on the quizzes for this section. So hopefully you're okay with setting it up. It's always going to be the outside equals 2 times the inside. I might even put this in parentheses or circle it or highlight it or something because you're going to use that a lot on the quiz. So let's try again. Here is a homework question. And just as a friendly reminder, every time you guys give me a homework assignment, you get plus 2 points extra credit. So what that means is you could get a 3 out of 5 on your quiz, but because you're giving me your homework, you're getting those 2 points back. It's like a built-in buffer every single day for your grade. So right now we're in Unit 4, so I'm accepting all Unit 4 homework still. Do it. It's a good boost to your grade. Can you imagine 20 points each unit if you've been doing it the whole semester? Those students all have A's right now. So do your homework. Let's check out our questions. So I kind of give you this picture. This is where Anthony's question is going to come into play about the whole 180 thing. It says, find the measures of the following intercepted arcs. So first it wants AB. Let's do AB in yellow. They want to know this measure. But in order for me to find that measure, I have to look at the angle that's directly across from it. So the angle that's directly across from that arc, I'm going to highlight it in red here, is right here. Oh, I think I might, I think I added this example last minute. Is this one not on your thing? I looked at one of your quizzes and there was a quiz question like this, so I added this right after I had printed them out. So let's take a quick second. Can we copy this one down, maybe flip your notes over? Sorry, this is the only one not in your notes because I saw it as a quiz question last minute. And then Austin Black, great question. We'll come back to that. Let's make sure everybody copies it down first. So really, you just need the picture with all the numbers in there, and then we'll answer A, B, and C together. If you're at home, can you give me a green check mark when you're ready? So again, I threw this one on here because I found a quiz question like it and I wanted to make sure that we covered it together. So sorry, this one didn't quite make it into the notes. You guys ready in the room with me yet? Okay. So let's go back and recap what it told us. It wants us to find the arc of A to B, so I highlighted that in yellow. And we know that there's a relationship between the arc and the inscribed angle across from it, right? If I know the inscribed angle, then I know that the arc is 2 times as much. How can I find this angle? What do you guys think? This missing angle down here. I'm going to put a yellow in there. Anybody know? What do you think, Tristan?
You can add together both of the angles of 67 and then subtract whatever answer you get by 180.
Perfect. So we're going to use our law of triangles and the fact that we know that all 3 angles add to be 180. So I can say my x plus 67 plus 67 is going to equal 180. Everybody agree with that? All 3 angles are going to add to be 180. So really what we're doing is we're saying 180 minus 67 minus 67. So far okay? With why well, first we need to find the angle and then we'll talk about why we did that. So my missing angle is 46 degrees. Everybody okay? Let's write a 46 degrees inside my picture. Why was it important that I found this angle? Because this angle is inscribed across from that arc. See how my angle's in yellow and my arc's in yellow? We can apply that same rule that we just did. The inside is x, the outside is 2x. So I had to find that inside angle first. So if it's a 46, Anthony says the arc is 92. Fabulous. So arc AB is 92 degrees because it's 2 times the 46. Everybody with me still? Okay, let's do it again. Now it's asking me about BC. So I'm going to change colors here. And Austin, I have not forgotten about your question. We're going to get to it in a second. So let's do BC. I'm going to do it in this greeny color. Here's BC. They want to know arc BC. They told me that the inscribed angle is 67. Do you guys see how the 67, if you follow your fingers along the angle, the 67 goes straight to that arc, right? Matches that arc right here. So if the inside is 67, Adrian, what would the outside be? 134. So BC is 134. It's 2 times 67. So now Austin asked a great question in the chat box. He said, isn't this an isosceles triangle? Isosceles means you have 2 sides the same. Is this isosceles? Yes, because I have 2 matching base angles. And then he asked another question. Since it's isosceles, doesn't that mean that once I find one arc, what would we know about the other arc? It's the same. Good job. Because it's straight across from another 67, right? So if this arc's 134, what's this arc? 134. So we found our last missing arc. I'll change colors one more time. So this one can be orange, and that would also be 134. It's straight across from the 67. So the big idea here is they're going to give you lots of triangles inside circles, but really what you're looking for is where does the angle meet the arc. That's all we have to do. It's just twice what the inside is. Are we feeling pretty comfortable with these, this type? Yes? Yes. All right. Questions at home? Anybody have a question watching online? Okay, so this was last week. We ready for our one new thing this week? Sure we are. Yes is the right answer. Yes, Miss G, we're ready. Okay, so this week we're learning about secant lines. Last week we did tangents. So let's review what a tangent is. A tangent is where your line touches your circle how many times? Once. Touches the circle once. That's a tangent line. Our secant line is one that crosses through the circle and touches twice. So let's point that that's a tangent line. So on your notes, can you draw a little arrow for me? So tangent, point to the tangent. Secant, let's point to the secant. Then we're going to get this third case where we have two secant lines. See how I have two lines that are going to both cross in the middle. Not in the middle, sorry, but have 2 points of contact with your circle. So let's review these pictures. The first picture is two tangent lines because they both hit one time. The middle one is one secant line, one tangent line. And the last one is two secant lines. Are we okay with the difference between the two? One touches once, the other one goes through it twice. Why is that important? Because they have different formulas. So one circle is going to have one formula, the other kind of line is going to have a different formula. We only have 2 formulas to learn. That's not so bad, not compared to some other chapters anyway. So here we go. Here's the first one. This would be a tangent. Do you guys see how it touches one time? Tangent and a secant. It says the measure of the inscribed angle is half the measure of the arc. Anybody notice anything familiar about this one? Think about the ones we just did. Yeah. X, 2x. We just did these. Everybody agree? We just did these? This is the same. The same formula. Doesn't, yeah, it does, but it doesn't make a triangle. It's the same formula, but it doesn't make this angle inside the circle. But what they're teaching you here is when you have a tangent plus one secant, you get to use the same formula. And you might be thinking, those don't look the same. Yeah, they are. Watch. If this was 50, putting in a number, this would be 100. Everybody agree? Just did those? Let's try it on my new picture. If this is 100, this inside they're saying it's half of that. What's half of that? 50. It's the same formula. So I don't want you to freak out and be like, oh, there's too many new things. No, it's the same formula. Not scary. So when are we able to use this formula? When you have an inscribed angle or when you have a tangent and a secant line. So you're able to use it twice. That's cool. Yay, we like that. Let's try an example. Whoa. Sorry, forgot to cover up all my work here. Okay. Here we go. You're like, I see it, I saw it. Okay, so let's try these. It's saying determine the measure of angle EDA. So what is it really asking me for? It wants to know this angle right here. Can you guys draw that in on your sample notes? It wants to know that angle. What is it giving us? It's telling me that the arc between A to D is 146. It's giving you the outside. How do you find the inside? What do I have to do to the 146? Divide by 2. You guys are getting the picture. It's not any different than what we just did. So 146 divided by 2, 73. So Isaac typed in the chat box, which is an excellent point. He said, so the first examples we just did were two secant lines. Yeah, that's exactly what they were. So if we go back to, well, even that one's 2 secant lines. So what was this? This one was a, sorry, my pointer's not grabbing, a secant line and a secant line. Cool. It's an inscribed angle, secant line, secant line. What were these? A secant line and a secant line. Pretty cool. Okay, so yes, that's exactly what we were doing earlier today. So when I have a tangent plus a secant, same formula. Yes, Anthony.
But it could be a chord because it doesn't go through the secant goes through.
Okay, yes. So technically, okay, now we're getting very technical. So technically, we could call it a chord, he's right, to stop from here to here, because a secant line technically does go through. So now we're getting very technical, but yes, they all mean the same thing on our circle. So. Oh, we could go around in circles today, yes. So let's try again. Okay. So you guys try this one. Determine the measure of arc DA and write it on your paper for me. And you know how I know who really grasps the concept? You're done. If you understand what we've been doing today, you are done. So if I'm giving you that the inside is 60, the outside is just twice as much, right? Which, Daniel, would be 120. Awesome. You got it. Any questions at home? What you should be saying, let me correct that. What you should be saying is, I'm so excited to take a quiz on this because I'm going to get 100%. That should be our attitude. All right, here we go. Next one. Okay. It says, it's giving you that this angle is 80, and it says, find the measure of arc DFA. I'm going to draw it in. DFA. I'm going to give you a moment to think about this one. Okay, who has a plan of attack? And talk me through your plan of attack. What do you think, Tristan?
Well, the first thing to do is to find the angle that corresponds with the arc. And the only way to find that is to use the complementary angle that you're given. Because a straight angle and another angle equals 180, you get 100 on the angle A and G, and double that to get B.
Okay, so there's two approaches. Tristan's saying, since this is along a straight line, if this angle is 80, that means that this angle has to be 100 because they would have to make the 180. That is definitely one approach, and then you could double the outside. Anthony, how did you try it?
Multiply or double 80, 160.
Okay, so let me stop real fast just so they hear it. So Anthony's saying the other way to do it is you take your 80 and double it so that you get that this arc is 160. Okay, and then what did you do?
360 minus 160.
So then he did 360 minus the 160 to get my orange arc. So there are two ways to do it. Yeah. Oh, and then you divide it in half to get, what did they want? No, they just wanted DFA. They only wanted DFA. So that's 200. But if I asked you, what's this angle, you could have said 200 divided in half is 100, which is the same answer that Tristan got. There are definitely two methods to solve these problems. Whatever works for you works for me because all of our brains are wired to think through problems differently. So it's absolutely fine. So two ways. Double it to get 160, and then we had 360 minus 160, 200. Or we could have said this one's 100 because it's along a straight line. Then doubling it would have been 200. There's two ways to think through the problem. They are both correct. Great job. So all of these examples have been the exact same type of problem. So now I have one last formula for you, and this is what we are going to finish our day with today. How is this picture different, you guys? Just state the obvious. It has two lines that do what? They intersect. They're kind of like two triangles. It's not in the very middle, exactly. They're intersecting, and it's not in the edge. That's exactly what I wanted you guys to see. These angles do not meet in the middle, and they do not meet at the edge. We've never done one like this before. This is our new formula for the day. This is the only new one. The last one we learned is the same as what we did last week. So these are for interior angles and the arcs formula. I did not include this on your worksheet. You need to copy that down. So let me give you just a moment. And Isaac Grillo, you know exactly where I'm going because I have that on my paper to ask you guys in just a moment. I love when you guys think ahead and you see where I'm going. So we're copying down the formula that we see. And what kind of lines can we say that these are? Okay, yes, Daniel, they're technically chords, but what kind of lines could we say these are? These are for two secant lines. Can you add that to this slide, please? These are for two secant lines. So let's break down that crazy formula and see what is this actually telling me. What am I going to use this for? This says if the measure of angle FEB, so what are they talking about? Right here. They're talking about this angle right there. Can you guys add that into your notes? Make it highlighted with your pencil, right in that little angle. That's what they're asking about. How am I going to find that angle? They're giving me a formula. I'm going to do 1/2 times the measure of arc FB. Let me change colors. I'm going to do 1/2 of this arc plus 1/2 of this arc. That's going to give me that green angle. So I'm going to do 1/2 of arc 1 plus arc 2. That's really what it's saying. See how I simplified it for you? That's my formula in Miss G's terms instead of all the crazy letters that they use. So how am I going to find that angle inside? 1/2 of the first arc plus 1/2 of the second arc. Here's my question to you, and this was Isaac's question. What can we say about this arc, about this angle right here? What do we know about it? It's congruent. Congruent to which one? The one right next to it. Why? What's the word? They're vertical. Vertical. They are across each other from the V. Remember, they're like forming that V. They're straight across the V. V for vertical. They're congruent. So that means once I know one, I know the other one. Guess what else you know? This is super cool. Well, we'll do it in the example. I'm getting ahead of myself. Any questions on the picture so far? We're going to try it. All right, let's try an example now. Let's put it to some good use here. So here's my picture. Start by filling in what we know. Let's add in what arcs are they giving us? What angles are they telling us? What information do we have? Can you add it to your picture? So I want to see you drawing on your picture right now, and then I'm going to draw on mine. So FB is 42, AD is 58. They want to know what the measure of AED is. AED. Everybody with me? Yes? Okay, let's type in my formula. It's 1/2 of arc 1 plus arc 2. So what am I adding together? 58 plus 42. Let's figure it out. What's half of 58 plus 42? So this would be what? 100. And half of 100 is 50. So what's the measure of AED? 50. This one's 50. I want you now to label all of the other interior angles on this circle, because once you know one, you know all of them. So start with the vertical angle. Go straight across and label it 50. Yep, I want you to fill in all of them. So straight across would be 50. I'm going to change colors because now I would like you to find a couple other things on my picture. I want you to find, what about this angle? What about that angle? I also would like you to fill in, what about this arc? What about this arc?
Okay. Yeah. Those are also vertical angles.
Are they also vertical angles? Good question. Are my two green ones vertical angles?
No.
Yeah.
Yes, they are. Yeah.
Wrong.
They're straight across the V. Yeah, they're straight across each other from the V. So let's start with the green. Who found the green? Okay, Sabella, what did you get?
130.
130. And how did you get that?
I subtracted 100 from 360, and then I divided it by 2.
Oh, okay. She did it kind of what I say is the harder way, but it's totally fine. Totally good explanation. Here's how else I think about it. A to B is a straight line. So if this is 50, the other angle would have to add to 180. So 130 and 50 makes 180. Straight lines are always 180. Those are supplementary angles. Okay, but your way's fine too. Same answer. So that means my other green angle is 130. What about my blue arcs? Now before I do my arcs, does anybody have a question about my green angles? Are we okay now? What about my blue arcs? First of all, are they going to be the same number or different numbers? Okay, they are going to be different. Anybody have an estimate or a guess? Okay, Anthony, what do you think?
AF is 138.
Okay, he says AF is 138. How did you get that?
Minus 180 minus 42.
Good job. Okay. Oh, okay. Let's talk about it. So what he's saying is he did 180 minus 42. So the question is, am I allowed to do that?
No.
Okay, I hear a no.
Yeah.
I hear a yes. These are great discussions.
Maybe.
Okay, maybe for Mr. Hayden. Let's start over. When is it 180? When it is half the circle. So here's the question. Is AFB half the circle or no?
No.
It's not half the circle. Why is it not half the circle? Because this line does not go through the middle. So guess what? I gave you a question you can't solve yet. And sometimes that's okay to do because it gets you talking and it gets you thinking. So we actually cannot find our blue angles just yet. We will. What would we need? Good question. Maybe it's a new formula that's coming next week. But I like to get you thinking. Not today. I just like to get you thinking. So no, the blues are not the same angle, or not the same degree, obviously, because one's small, one's big. But I was really trying to get you guys to see, can you just say, hey, those are supplementary, they add to 180? No, only if it goes through the middle. Yes, Anthony.
I just noticed that this dot with a C is
Yes. So the dot with the C means center, and they'll give that to you on tests and things like that just to show you, hey, these are not going through the middle. So if they ever give you the dot C, they're just showing you where the middle would be. Good. Exactly. None of the lines go through the middle. Okay. Your turn to practice. So I'm going to stop, have you guys solve this one. I'm going to walk the room for a minute, and if you're at home, go ahead and work on this one. And just like in the last example, if you guys could find all of the interior angles for me, just like we did before, that would be excellent. Okay, great. I see a couple people typing their answers in from home, so you guys go ahead and do that if you are at home and you are ready. All right, so let's try. Ready? Arc FB is 64, and arc AD is 32. Okay, so Adrian, can you give me your formula though? What did you do? Mm-hmm.
AED.
Okay, the measure of AED equals?
1/2 measure of arc FB.
Okay, so what is that measure? 64 plus 32. Great. So we have 1/2 of, what's that number? 96. And half of 96 would be 48. If one's 48, what does that make the other one? 48. Why? What's our reasoning? Because they are vertical angles. Okay, so now let's find my alternate angles. Now I'd like to find this one and this one. So let's start off with AEF. Do AEF. How come this time I'm allowed to say 180 minus 48? Because you're allowed to do that this time. How come on the outside I can't do that, but on the inside I can? Why? What do you think, Tristan?
Because it doesn't matter what one goes through the center, the supplementary angle is the right half of each center.
Perfect. So he said when you're talking about a line in the center or a line through the middle of the circle somewhere inside the circle, so it doesn't have to be through the middle. A line is a line, meaning a line's always straight and flat, right? So it's always going to add to be 180 because those are always supplementary. When is the outside 180? Only if the line's straight through the center. So a line is a line, but an arc is only 180 if the arc goes all the way from center to center. Good job. So my other ones that are missing would be 180 minus 48, which is
132.
132. Great job. Okay, so if you're at home, you guys are going to, if you're in person, we're going to do something on the whiteboard, so hang in there with me for just a moment. And if you're at home, you are going to do a great job of answering this question. When you have two secant lines that cross inside a circle, what formula do you use to find the measure of the interior angles? So if you're at home, thanks for joining me. Go ahead and submit your essential question, and I will see you guys next week.